Okay, the next part of this chapter deals with transforming graphs. Now, in order to help you remember how to transform graphs, I'm going to tell you a story. So it's Jackanory or Bicanori. It's a line story. Now, what I'd like you to do is just close your eyes, just relax, and just listen to the story. You can feel the sun on your back, very, very warm. Feel a slight breeze running through the air, and you're on the African plains because you are a lion. Now, you're a very proud lion. You've been very successful. You are the king lion of your herd, of your pack. The lionesses have been very successful. They caught a zebra early in the day and you've munched on a bit of zebra. You're a very happy, content lion. But then all of a sudden, you feel a sharp pain in your backside. You turn round, there is something sticking in your bum. And suddenly, you get wheezy and woozy and you fall into a deep, deep, deep sleep. When you wake up, you look around and you realise you have fate worse than death. You're in a cage and you're in Dudley Zoo and there's these little children looking at you, waiting for you to do things for them, waiting to entertain them. But that's not your job. You should be on the African plains, so you're not very happy. Now, believe it or not, that helps you learn how to transform graphs, because we have two moods. We have a mood when we're in a cage, when you're in brackets, or when you're outside a cage. When you're outside the cage, you're happy. When you're inside the cage, in Dudley Zoo, you are sad. Now, there are three types of transformations we deal with when transforming graphs. We deal with translations. That's all about shifting graphs. We deal with enlargements. And we deal with reflections. There's no rotations in AL, so we just deal with those three. So translations take the form of either f of x plus a, if you're outside the cage, outside the brackets, or f of x plus a if you're inside the brackets. Enlargements when you multiply, so a lots of f of x going outside the cage, f of ax inside the cage, so that'll be an enlargement. Reflections, well, that's all about when you flip out, when you flip, when you reflect, and that's when you're negative, because negative people generally flip out from time to time, as we're all fully aware. Going outside the cage, inside the cage. Now, if you're in a cage, or you haven't got a lot of room, all you can do is lie down. So when you're in a cage, it's all about the horizontal, it's all about lying down. When you're outside the cage, it's all about the vertical. You can jump up and down. You're happy. Who wouldn't be happy on an African plain, belly full of zebra? What's not to love? So, well, translation's all about shifting. So if you've got a graph f of x plus a, that needs to go a up. You'll shift the graph a up. So you're going to add a to the y coordinate. F of x plus a, intuitively you would say that's a to the right, but it isn't, because if you're in a cage, if you're at Dudley Zoo, you're not happy, you're awkward. If someone tells you to go a right, you no, you're going to go a left. So this is going to be take away a from x. Multiplying, if you're outside the cage, if you're on the plains and you're happy, you times it by a, you're going to stretch by a factor of a. So you're going to times y by a. You're going to basically stretch it about the x-axis. You pull the graph that way. Inside the cage though, inside the cage it's very squashed. So you're going to squash by a factor of a. So you're going to divide the x by a. So you're going to squash it by a factor of a. Reflections. This is when it's reflecting vertically, you're going to be changing y. So you're going to just turn it upside down. So it's upside down. Change sign or signs of y. When it's flip it this way, it's all about horizontal. So it's flipping this way. Flip about the y-axis. Going to change sign of x. Another thing you can remember is if it's next to the x, it affects the x. So when you're in the bracket, it's going to affect the x coordinate. When it's outside the bracket, it's going to affect the y coordinate. Just need to remember that. So adding, translation, times in, multiplying, enlargement. Even if it gets smaller, that's still classed as enlargement. So a squash by a factor of a is actually an enlargement by 1 over a. It's still, even if it's getting small, it's still classed as enlargement. And reflection if it's got a negative. So those are the 3 types of transformations you need to remember. So looking at example 9, now this next part of the chapter just deals with translating graphs. We're asked to sketch the graph of y equals x squared, x should be x minus 2 squared, and x squared plus 2. So let's just start off with just a basic, simple quadratic graph. Going through the origin happily, all good. And that's f of x. So f of x is x squared. Now in B, we want to do x minus 2 squared. So the minus 2 is inside the bracket. The function is to square it. So now we're squaring x minus 2. So it's going to be f of x minus 2. So that's the input, and the function squares it, x minus 2 squared. So that is inside the bracket, so it's all about the horizontal. You're in the cage, all about the horizontal. It's indicating to go to left, but no, awkward line. You're going to go to right. So it takes this graph and shifts it to right. So the turning point at 0 is going to be shifted onto 2, and you can work out when x is 0, minus 2 squared is 4. So that's what it's going to look like. C. Y is x squared plus 2. So it's plus 2, it's still a shift, still a translation, but this time that's outside the bracket. Because if f of x is x squared, to get x squared plus 2, we're doing f of x, x squared plus 2. So that's 2 outside the brackets, so that's 2 up. So we take this graph and go 2 up. One common error is, after students have done part B, they'll then shift this one 2 up. That's a completely different question. This graph 2 up, which is simply this graph 2 up. Okay, on to example 10. F of x is x cubed. Now an x cubed graph looks like that. And what we want to do in part A is f of x plus 1. So you think one right. Remember it's plus, so it's a shift inside the bracket, so it's all about the horizontal. You're thinking one right, but no, one left. So you've taken away 1 from the x coordinates. So all that does is that point of inflection there just goes 1 left. So A is going to look like this. So it crosses the y-axis when x is 0. When x equals 0, well, we need to think of what the equation is. Remember, the function is to cube it. So this is x plus 1, the input value cubed. So when x equals 0, you've got 1 cubed, which is 1. And that's going to be minus 1 because you've got 1 left. B. So x minus 2, what's that going to look like? That's going to be obviously a quadratic, happy, going through 0 and 2. So it's going to look something like that. And then we want to change the input value from x to x plus 1. So it's going to be x plus 1 times x plus plus 1 minus 2, which is x plus 1 times x minus 1. That's what the new graph is going to look like. That's g of x plus 1. But in terms of what we need to do, it's exactly the same as the last one. It's going to be 1 left. So I'm going to take this graph and go 1 left. So it's going to go to 1, minus 1, 1. But you can see that from that, it's going to be minus 1 and 1. So it's simply going to be, and that would be 1 because the symmetry, so that's going to now be on the y-axis. When x equals 0, minus 1. Okay. Sample 11. Sample 11 first asks us to sketch h of x plus 1 where h of x is a reciprocal graph. We should know what the reciprocal graph looks like. It just looks like that. Asymptotic to the x-axis and y-axis. That one looks like it touches it, it's not meant to. We need to sketch h of x plus 1. So that's plus 1, so that's outside the bracket, happy, vertical, 1 up. What that means is at the moment it's asymptotic to the x-axis, so it's going to shift 1 up. And the way we represent that on the graph is just with a dotted line going through y equals 1. That's going to be an asymptote. So the only thing left to do is work out where it crosses the x-axis. Well, h of x plus 1 is going to be 1 over x h of x plus 1. When does that equal 0? Or 1 over x equals minus 1. 1 equals minus x, x equals minus 1. Okay. So crosses the x-axis at minus 1, asymptote at y equals 1. That's the general sketch. So if we have a go now, exercise